IP4 private addresses, public addresses. At the heart of every single conversation on the global internet lies the Internet Protocol, or IP. It is the fundamental addressing scheme that allows a packet of data to find its way from a server in California to your computer in Buffalo, New York. Without IP addresses, the internet would be nothing more than a pile of disconnected hardware. To truly master this system, you must understand the structure of IPv4, the critical wall between public and private addresses, and the clever trick called NAT that keeps the world connected despite a massive shortage of available numbers. The anatomy of the IPv4 address. An IPv4 address is a 32-bit binary number. However, because humans are not very good at reading long strings of ones and zeros, we write them in a format called dotted decimal notation. A standard address looks like 192.168.1.50. This address is divided into 4 sections called octets. Each octet represents 8 bits of binary data, which means each number can range from 0 to 255. Mathematically, a 32-bit system allows for about 4.3 billion unique addresses. In the early 1980s, 4 billion seemed like an infinite number of addresses, but with the explosion of smartphones, IoT devices, and global connectivity, we ran out of new IPv4 addresses years ago. This scarcity is what created the 2 distinct worlds of IP addressing, the public world and the private world. The public world, global identities. A public IP address is a unique identifier that is visible to the entire world. Think of it like the legal mailing address of your house. For a letter to reach you, your house must have a number and a street name that no one else in the world shares. Every server hosting a website, every mail server, and every router connected directly to the internet must have a public IP address. These addresses are managed globally by IANA, the Internet Assigned Numbers Authority, and distributed locally by your ISP, or Internet Service Provider. When you sit at home and search for a website, your router uses its public IP address to talk to the rest of the world, because these addresses are unique and globally reachable. They are the gold standard of connectivity. However, because they are so rare, your ISP usually only gives you one public address for your entire home or office. This is where the private world comes in to save the day. The private world, internal identities. If the public IP is your house's mailing address, a private IP address is like the room numbers inside your house. While the mailman only cares about the front door, you need a way to tell the difference between the kitchen, the bedroom, and the living room. Private IP addresses are used inside a local area network. They are not unique globally. In fact, millions of people around the world are likely using the exact same address, 192.168.1.10, at this very second. This is perfectly fine because these addresses are non-routable. They are designed to stay hidden behind your router and never travel out into the public internet. To ensure there is no confusion, certain blocks of numbers were set aside by the IETF, specifically in a document called RFC 1918, to be used exclusively for private networking. As a technician, you must memorize these 3 ranges. First is the Class A range, 10.0.0.0 through 10.255.255.255. This range provides over 16 million addresses and is used by massive corporations and government agencies. Second is the Class B range, 172.16.0.0 through 172.31.255.255. This is typically used by medium-sized organizations. Third is the Class C range, 192.168.0.0 through 192.168.255.255. This is the most common range, used in almost every home and small business in the world. The bridge, NAT, Network Address Translation. You might be wondering, if my laptop has a private IP that the internet can't see, how am I watching a video right now? The answer is the most important trick in networking, NAT, or Network Address Translation. NAT is a service that runs on your router. It acts as a translator between the private and public worlds. When your laptop, with its private address, tries to reach Google, the request goes to the router. The router swaps your private address with its own public IP address and sends the request out. The router keeps a translation table in its memory, noting that laptop A asked for this specific website. When Google sends the data back to the router's public address, the router checks its table, swaps the addresses back, and delivers the data to your laptop's private address. This allows hundreds of devices to share one single public IP address, which is exactly how we survived the IPv4 address shortage for the last 20 years. Static versus dynamic addressing. In both the public and private worlds, an address can be assigned in two ways, static or dynamic. A static IP address is one that is manually assigned by a technician and never changes. This is vital for servers, printers, and routers. If your office printer's IP address changed every day, your computers would never be able to find it. In the public world, companies pay extra for a static IP so that their websites and mail servers are always reachable at the same mailing address. A dynamic IP address is assigned automatically using a service called DHCP, or Dynamic Host Configuration Protocol. This is how your smartphone and laptop get an address. The device asks the network for an address, and the DHCP server, usually your router, leases it an available number for a set amount of time. This is efficient because it ensures that addresses are not wasted on devices that aren't currently using the network. Specialized addresses, loopback and API-PA. To master IP addressing, you must also recognize two special types of addresses that indicate a specific status or problem. First is the loopback address, 127.0.0.1. This address refers to this machine. It never leaves the NIC as a technician. You use this to test your own hardware. If you can ping the loopback address but can't reach the internet, you know your internal networking software is working, and the problem is likely your physical cable or the router. Second is the API-PA address, 169.254.x.x. If you ever run the ipconfig command and see an address starting with 169.254, it is a major red flag. This stands for automatic private IP addressing. It means your computer tried to talk to the DHCP server to get an address, but no one answered. Your computer then assigned itself this emergency address so it can at least talk to other computers in the same room. But it will have zero access to the internet. Subnetting, dividing the network. As you progress toward your degree, you will dive deep into subnetting. This is the art of using a subnet mask to divide a large pool of IP addresses into smaller, manageable groups. The subnet mask, usually something like 255.255.255.0, tells the computer which part of the IP address is the network ID, the street name, and which part is the host ID, the house number. By changing the mask, an administrator can create isolated subnets within their organization. This is critical for security and performance, as it prevents a broadcast storm in one department from slowing down the entire company. Security and IP addressing. From a cybersecurity perspective, understanding IP addressing is your primary defensive skill. A hacker will often use an IP scanner to find every active private address on your network, looking for an unsecured printer or an old server with a known vulnerability. As a defender, you use this same knowledge to configure your firewall. You write access control lists that allow traffic from your trusted private IP ranges, but drop any suspicious traffic coming from unknown public IP addresses. Furthermore, you must be aware of IP spoofing. This is where an attacker fakes their source IP address to make it look like they are coming from a trusted internal machine. Modern firewalls use anti-spoofing rules to detect when a packet claiming to be from a private address arrives on the public side of the router, which is a physical impossibility and a clear sign of an attack. The future, IPv6. Finally, we must acknowledge that IPv4 is a legacy system, while it is still the king of local networks. The global internet is slowly moving to IPv6. Instead of 32 bits, IPv6 uses 128 bits. This allows for a staggering 340 undecillion addresses, enough for every grain of sand on Earth to have its own IP address. However, because IPv6 uses hexadecimal notation and a completely different structure, it is a massive challenge for organizations to switch over. For now, mastering the public versus private world of IPv4 remains the most important skill for any IT professional. By understanding the structure of the octets, the ranges of the private classes, and the vital translation power of NAT, you will be prepared to design, manage, and defend the communication pathways of any organization.